Okay, now, just because this question isn't hard enough, they are bringing in complex numbers. So now we have f of t is this function, which basically means L of t is f of t plus d, and we have d from the previous part is 12.49. Okay, so we want to basically find f of t. If we can find f of t, we can write it like this, and this is essentially what they're asking us to do. But first, he says f of t can be written in the form the imaginary, this is the imaginary part of z1 minus z2, where z1 and z2 are complex functions of t. Write down z1 and z2. Okay, so if you recall, guys, so this is going to be our z1 and this will be our z2, but it's the imaginary part of z1 and the imaginary part of z2. So the imaginary part of a complex number, if you remember, well, let me just give you this, cos theta plus I times sine of theta. So the imaginary part of a complex number, or sorry, I should put an or before this. And this is your or cis theta, or cos theta plus I times sine theta. The imaginary part of this z is just going to equal or sine theta. So the imaginary part of z here is going to be the 1.5 sine of this. So theta is essentially whatever's in this bracket. This is theta. And the or is just the 1.5. So z1 is equal to 1.5. Well, let's start with cis theta, which is 0.00939 t plus 2.83. But he says write down z1 and z2 in exponential form with a constant modulus. So this is 1.5 e to the power of 0.00939 t plus 2.83 I, because in exponential form it's or e to the I theta, or theta I. So that's z1, and then z2 similarly, I'll just go straight to the exponential form. It's 1.6 e to the, this is theta, so 0.00939 t I, like that. Okay, that's z1 and z2. That's 3 marks, not too bad. This bit is the tricky bit. Hence or otherwise find an equation for L in the form of this. So this, guys, is the adding. We're adding 2 sine functions together with equal frequency and different phase shift. So you may recall this lesson that I did. It's talking about turning AC current to DC current and like alternating current to direct current. It's a nice real life example of complex numbers and their use in the real world. How do we do it? Well, we get we're going to get the imaginary part of z1 minus z2. So z1 minus z2, let's just get this first. z1 minus z2 is 1.5 e to the 0.00939 t plus 2.83 I minus 1.6 e to the 0.00939 t I. Now, what can we take out? What's common here? Well, this, because I can write, let me just do this slightly different. I can write this as this I times e to the 2.83 I, because that's just adding the exponents. So this is the same as this. And what's common now, I can take out the common factor if you like. That's my e to the 0.00939 t I. So I'm taking that out of here and here. And what's left? Well, my 1.5 is there. My e to the 2.83i and my 1.6. And this is, I've taken out of the bracket. Okay, now this is e to the 0.00939 ti. And this bit I can do with my calculator. So this is just 1.5 times e to the power of 2.83 I minus 1.6 gives me this. Now I want it in, I would like it in exponential form, so I'm going to go menu, number, complex numbers tools, and convert to polar. Okay, so this is now 3.06249, 3.06249 e to the power of 2.99086i, 2.99086i, 99086i. Okay, very nice. And then what can I do with this? Well, I can write this as take out the 3.06249 in front, and then again I can add the powers here using our first laws of indices, and it's 0.00939 t plus this plus 2.99086 I, like this. Okay, so this is Z1 minus Z2, nice. This is in exponential form, or e to the I theta, so this is my theta. And he says f of t can be written as the imaginary part of this. So the imaginary part of Z1 minus Z2 is just the sign part, because remember, it's a complex number is or cos theta plus I times sine theta. The imaginary part will just be the or sine theta. So let me get rid of that. The imaginary part of this will be my or, which is 3.06249, sine of this angle, sine, this is the angle, 0.00939 t plus 2.99086. So he says, hence or otherwise find an equation for L in the form of this. So it's, I have my P, I have my Q, I have my R. The only thing I don't have is the D, but I got D in the previous question. It's 12.49 because it's f of t plus D, and I've got f of t, so it's 12.49. So all I have to do now is write, therefore, L of t is equal to 3.06. I'll just go to three significant figures, guys. 3.06 sine 0.00939 t plus 2.99 plus, what did I say, 12.5. Let's go with plus 12.5. Okay, that's L of t. That was not easy, guys. One more part of this question.